is Search in Django. And he's here. I'll give you guys the front matter. That's who I am. Benny Lope. That's who I'm on Twitter, GitHub, pretty much everywhere. I leverage a lot of synergies, and those are the URLs there. I'll later post these slides in case you want to do them again. These are the takeaways for the talk today. These are like my goals for you guys here. I'm kind of approaching search as a thing that needs to be understood as its own problem, and I want to explain the role of the search engine. We're talking about search. We're not talking about like Google or Bing. We're talking about a service you're using to search all the content in your own site. You're gonna map that content. Understand what you can do with the search engine, and one of the probably the key thing I'd like you to leave with today is having at least a decent understanding of how to start with Haystack. Django Haystack is the kind of the default library you use to integrate search functionality into Django site. So give you some of an understanding of how to do that. And we're actually going to look at a sample app when I'm kind of done with the slides. And then a little bit of some of the limitations of Haystack specifically. Hopefully I'll remember where I didn't label it, where some of the gotchas are, where some of the key takeaways are throughout. So there are some little things that I think are important to understand and to be aware of when you're starting out integrating search, especially with Haystack, into your project. So this is the search problem. You're searching textual content. I think it sounds kind of like a truism, but it's very important to understand this is what we're doing here. You've got a corpus of text, whether it could be articles, it could be records of things people have done, maybe the medical records, and you want to be able to search for words or phrases and find things that match. So that's really the gist of what we're trying to do. I'm gonna talk a little bit about using a SQL database. Maybe that's what we're all used to using, kind of an analogy. But that's kind of where it's very different at that point. You're not getting related data, you're just searching text. The way we do this is with search engines. Again, I'm not talking about Google, I'm not talking about Bing, we're talking about another service. It's a service that's basically, it's used for indexing textual content. And it's used for doing that in a document format. So that's really the key difference is if you've got Postgres or MySQL, you have a whole bunch of tables, and maybe you've got some text content in there, and you can do some searching on it. But we're talking about you want to search just the search engine is taking stuff and putting it in a document format. And it's basically, this is what it is. It's an inverted index. It's got all of your content, and it's got all the words or phrases or however else you want to break up that content, and it's just mapping where those words and phrases are in that body of text. So I mentioned SQL. You can actually do some full text searching with a relational database system. MySQL has some full text searching out of the box. Postgres offers some of that functionality. There are some key differences in how they work, and when I get to some of the features that some of these search engines offer, I think you'll start to kind of understand why the rationale for using an additional service rather than doing this from within, let's say, Postgres or MySQL. I said it's a document. You're searching this document database, so why not MongoDB? That, to me, is one of the next questions. The answer is that Mongo is only a pawn in game of search. Remember, we want to talk about, it's about the index, okay, not just about the documents. So these are some of the more popular search engines, and I'm going to talk about later, primarily Elasticsearch is at the top. Elasticsearch and Solr are both based on Lucene, which is a Java library. It's very popular, and they're both, Solr is a very mature product. You could use Solr and know it's going to work, and it's pretty full-featured. Elasticsearch is a little bit newer, and development is moving pretty quickly. Whoosh is pure Python. As a result, it's going to have some more limitations in terms of like performance. If you have a huge amount of text and you want to do a lot of searching, a lot of indexing. And Sapien and Sphinx, not going to touch on this at all. They're there. So there are two aspects. There are two things we need to do when we have a bunch of text we want to search it. One is we have to get it into the index. We want to get it into the search engine. And this turns out to be a very important step. Because it's not just about dumping stuff in there. We're actually going to be mapping that to our index. The way we do that is with a concept called an analyzer. An analyzer it's a combination of a token and some filters. And basically, this is a way of breaking up your text, transforming it, and then placing it in your index. And it'll become pretty apparent why we do that. But as you can probably already imagine, if you want to search for variants on a phrase or some to that effect, you need to do something else to that content. So we've got tokenizer and filters. Stemming is probably the most obvious, or the first use case for this. Stemming is breaking up words into their components, and not necessarily just their syllabic components, but the roots of the word itself. So this is going to be one of the gotchas, is that stemming is language specific. There are a lot of English stemming algorithms out there, words, but it is language specific. So if you want to do search in a different language or multiple languages, you need to have a stemming system for each single language. Another is taking n-grams. This is something you do for, as an example, autocomplete. N-gram would be taking a letter and breaking it up into tokens that are of, let's say, usually of a uniform length, like a 3-letter component. So if we took stemming, you'd take here 1 piece, 2, 3, and using those small tokens, those grams, you can then search for components of words and partial word matches. So these are, just look through some of my own mappings and Elasticsearch documentation, and here's some of the other tokenizers and filters that you'd use that I think make sense. Stop. You want to break. You don't just break stuff apart. You also want to remove words that are useless. So you might have a whole list of stop words. Again, these are going to be language specific. Like articles, conjunctions. You probably just don't want to bother indexing that stuff. Synonyms. That's a more of an advanced search feature. If you have a product, let's say, and you want people to be able to search for something that's similar, so we're going to have synonyms. Or you've got other text that people should match. And then filters, of course, this is where we're going to be just transforming text, not necessarily breaking it apart. Lowercase filtering, that's pretty common. You wouldn't most likely want to be indexing words differently based on capitalization. Okay, so these are the transformations you're going to make. The second step, and they're both necessary, is getting data out. So querying the search engine. This turns out to be a little bit more familiar to us. Where basically it's not exactly like we're not going to form these queries like SQL queries, but again we're describing where we want to get data from and how we want to get it out. I don't know why I put this in here. So this is go through a list of some of the more advanced things you can do with querying. You can get facets. So if you've got a body of text, you're actually going to be searching the text, but you can have metadata for that text. And these are going to be the facets. So if you've searched for something, let's say on Amazon, and you've got all the departments or the product types, those are facets for that data. And you can filter down on that data by these facets. You can highlight result text. I think everybody's seen this. You can do spell checking. This is going to be on the input that people are searching on. I mentioned n-grams and being able to do autocomplete with those. And geospatial search. This is something that I found useful. If all you need to do is basically take a bunch of objects in your database and map them, or do some sort of do something with them based on their location, I would first suggest you probably just use something like PostGIS. It's going to be a little bit more accurate and faster at some of the geospatial queries. But when you want to combine text search with them, you can do that all within the search engine. Not all of them. And I think I should have put this slide later. But so there's some things you can do to improve performance of your searches, but we're not going to talk about them today. I've done that one. I did want to address search engine as cache, and I want to be clear is that search engine should not be it's not a replacement for a cache. It's not something you're going to have this and drop it in place of memcache. But it is a document data store, and when you're getting results out, you can put data in that's indexed. You can also just put data into that document that's not indexed at all, which means that when you get your result, you can grab that and spit it out too, rather than doing another database query later. Improving quality, though, which is not the performance, but the relevance of what people do, is this is where there's a lot of room to do some tweaking on your setup. One of the features that Solr and Elasticsearch offer is boosting. What this means is you can artificially change the relevance of results. So again, if you have let's say you have a list of products, or you've got a product database, and when people search for something, you'd really like them to get featured products first. Maybe it's the product of the month. You can, whenever you index these products, you can say whenever a product happens to be featured, we're going to boost its score. We're going to take its score and we're going to add this multiplicative factor so that it's artificially going to have a higher relevance score. That's one example of how you can do that in one place, but that's what boosting lets you do.
Can you only do that at next time?
No, you can do it at query time too. What I've seen with boosting at, let's say, at query time is sometimes you can just give it like a single value. So I don't think it's going to be a multiplicative, like a factor, but say, oh, this document matches this, give it 10, and it's probably going to be your first result. So this leads us to Haystack, which is sort of why everyone's here, or hopefully why you're here. And this is where we're going to get a little bit more into how you actually start implementing this in the Django project. I want to be clear that it's just abstract. It's just a layer of abstraction. In fact, Haystack's a layer of abstraction. It's a Django-based layer of abstraction over a Pythonic layer of abstraction. If you're using Haystack with Elasticsearch, you'll use PyElasticsearch, which is the library to interface with Elasticsearch. It's really simple because you communicate via JSON to Elasticsearch just over HTTP. So you're basically just using JSON and requests. That's all it's doing. But it simplifies it a little bit. And Haystack lets you do that in a way that's a little bit more familiar to a Django library. So this is a takeaway and a gotcha. Haystack is ORM-oriented, and that means two things. One, it's easy to think of it kind of like another model mapping, just like the ORM, but it's doing something different. And the other aspect of that is that it is really focused on the Django ORM. You're going to be mapping models to documents. So if you're doing something very different, if you're not using the Django ORM, you'd probably have to, whether you can use Haystack or not, you'd probably have to do something funky with it, because it is really focused on the ORM.
So it probably wouldn't play well with like SQL Alchemy.
I would think out of the box it wouldn't. I don't. Let me come back to that because I think there's might touch on a couple of the components where you might be able to make that happen, but I don't know for sure. This is that key takeaway I was talking about regarding the ORM. This is just a mapping. So it's not taking data from the database and just directly sticking it into the search engine. You're telling it what data to stick in from your model and how to process it as well. So if you've got a model and it's got 20 fields, you might have a search index that maps to that model, but you might only put one field in there. And that field might be aggregated over multiple fields. It doesn't have to be, it's not that data from your database into the search engine. Again, it's just a mapping, and you have a lot of control over how that works. When you are developing how you're mapping this out, what I really think is you should start from the perspective of the search, like the search page, that endpoint. rather than your data, think what kind of results you want to get back, how should these look, and then start mapping your models to that kind of standard search document. So we're going to do the haystack components. The search query set, mentioned it's kind of ORM-oriented. The search query set, it tries to stick pretty closely to the query set API. So if there is, for instance, if there is a form that is going to apply, rather not a form, but the search index, if you're going to be getting data out of your ORM at SQL Alchemy, as long as the object kind of looks like a query set, it should work. And it really just, it needs to have the same attributes. I think that's really what matters. But the search query set is very similar to the query set API, from the lookups to how it behaves into filtering. The search form, this is a form class that ships with Haystack. You don't actually have to use it. The search query set is really the key component you use. Search form kind of behaves a little bit like a model form, insofar as there's another method on it that you call and that instantiates or executes something against the backend. So that's what we're going to use for calling the search. And then Haystack also ships with search view. So there's a default view class, and a gotcha here is that the view class was added to Haystack before class-based views were added to Django. So it works differently. It's a different API, and it's not going to be compatible with your standard Django class-based views. So I mentioned getting data into your search engine. The way one of the ways you're going to do this is by actually using some of the management commands that ship with Haystack. From these management commands, you can clear your index, you can build it, you can rebuild it, which is just chaining those two commands together. From these commands, you basically have all the control that you will need over cleaning, updating, or adding new data to your search engine. You can do this based on the age, which you configure in the search index. You can remove stuff that's not supposed to be there. So if you run an update command and you say, I want to update based on this model, Haystack's going to generate a query set of every object that should be added based on that model, and then it's going to check for missing items in the search engine and delete those. So it's a fairly handy way of keeping it clear. I mentioned some of the gotchas. I've already addressed some of them. There are one of the big gotchas that I found when I was starting with Haystack is that it's easy to think about, see the search index, let's say, and you have a field, and to think of it as just a character field. Let's say it's a name. And then to think later you can sort on that name, because it's just a character field. It's maybe the name of a product again. The problem is that you're sorting on something that's stored in the search engine, and the search engine is likely not storing it as a single character, as a single string. It's storing it as an array of strings, as these tokens, and you can't really sort on that. So that was one of the big gotchas. When it comes to debugging search issues, one of the friends you will find is the Django debug toolbar plugin for Haystack. So if you're not using Django debug toolbar, you should. Exceptionally handy, and it's going to give you some feedback about what's going on in your templates and your queries. And this will do the same thing for Haystack. Tell you, what's going in, what's coming out. There's another thing you can do, which I'll address at the very end, which is a library I created as a helper myself. It's not really production ready, let's say, for everybody else. That'll give you some insight into how your mapping is set up for your search engine. If you're testing with Haystack, this is where you have to do a little bit more on your own. When you're testing with your database, you can use fixtures. You can use fixtures with Haystack too. You just need to manage those yourself. So you're not just going to add a fixtures attribute to a test case, and then when you run test, have that stuff all dumped into the search engine. You're going to need to manage that yourself again. So if you're not doing that, you'll probably want to either add stubs or mock some of the search functionality. All right, now we're going to Elasticsearch very briefly, because this is the search engine that I've been using. And again, it is Lucene-based and offers a lot of similar functionality to Solr, with a few key differences. One, it is you communicate via JSON, so it's JSON in, JSON out. It is cloud ready. It has a feature for doing some auto discovery on a network. To install, it's pretty simple. You can install with Brew if you're on a Mac. There's a link if you're not using Brew, if you're not familiar with it. If you're on a Debian-based system, you can just download the Debian file. If you're on Windows or Fedora, I don't know. You can build from source. So I'm gonna. This is the key thing. I mentioned you're mapping your content earlier. You can get it from, whatever fields you want into the search engine. Since again we're putting just content there, text content, you can use templates to get this. And then I actually don't think I had this in my example later, but it's pretty straightforward, and it's in the Haystack documentation. So files. This is something I had really hoped to touch on in the example too, but sorry, we're not going to. This is kind of where if you come from an enterprise search, if you have a background doing enterprise search at any level, this is one of the things. This is why you have search. It's because you have documents, you got PowerPoint presentations, and you've got Word documents and all kinds of other crap, and people want to be able to search this. You can do that with these search engines, not out of the box the way they work. Again, they're just searching text. So if you have these binary files, what you just need to do is extract the text from them. There's a couple of ways to do that. Well, first of all, if they're just text files, you can read the text in. If they are binary files, the likes of PDFs or Word documents, what you use is another library. That'd be the most efficient way. Another library, like something like Apache Tika, and that is a Java library. And you can actually run it as a service. If you had some other weird system you just wanted to use. But basically, you take a document, like a Word document or PDF, put it in, and out comes just the text from that document. So all of a sudden, it's searchable. And that's exactly what these enterprise search tools are doing. All right. We'll address this in the example. So, last takeaway, search is hard. It requires a little bit of tuning. You're going to have to work with it. When you're executing SQL queries, what you want to do is, if you've got a big query, you want to try and optimize it. You're trying to get it to work more quickly. But ultimately, you know the data is coming out as right. With search, there is typically not a right answer. People are putting whatever they want to. They're searching on just human input. And you're trying to get documents that match either what they're trying to find or what you want them to find. Those are both actually valid strategies or valid outcomes. So there's a lot of tuning. There's rarely a binary answer. So now I want to actually look at some code with you guys. This is what we're going to be looking at. It's a really small app with just a little bit of data. I underestimated how much time it's going to take me to relearn Scrapey to get the data in there. But all the source code is available, and we're just going to walk through a few examples to show you how this works. So this is our app, and
great design.
It is. It took me a while to really get the typography right, but it did. What this is it's a tiny app. It's supposed to be based on the CIA World Factbook. I was originally looking for a corpus of data that I thought would be structured, that would have content, would be facetable, that would have geographic data. The CIA World Factbook has all of that stuff. The HTML is a mess. And it was easy enough to use.
Quick question. When you say facetable.
Oh, what? Sorry.
I know you mentioned earlier, but in this example.
Actually, facetable is kind of a weird way. There were a lot of things that are. Let me explain by showing.
Sure.
There are 6 countries here. good, right? So I took the government type from every country in there. Albania is a parliamentary democracy. And what you could do is you could list every parliamentary democracy. That's a facet, the type of government. Population is not a facet, that's a metric, but we can actually make a facet out of population by dividing countries into segments of population size, and all of a sudden that's a facet. Religions, maybe that the country, pulling data from this area will affect what religions that the country has, maybe anything like that. I mean, numeric things are not going to be facets, again, unless you chunk them into brackets. Then the brackets are facets.
Like date ranges.
Yeah, exactly. Like the date itself. Well, a date could be a facet. Actually, you have events on a date, but most likely you want to just get the year rather than the date something happened.
So then would it be appropriate to call a facet something more like let's call it a classification of a group of objects, a title for a group of objects?
It could be.
But you could also select, like, if every document in your index has an array of things, you could select for, that array containing something. So it's not necessarily just the value of a field. It could be.
Well, yeah, then it's sort of a group of arrays. But it's sort of a title for that particular sorting.
The idea is you could search like USSR and it would pull up all the former USSR countries. And then a facet would be ones that are now parliamentary democracy, right? So you're like filtering your results. As the user, you're like narrowing your search. It's that kind of thing.
Yeah. So anything you can make basically a drop down or a checkbox list, that would be a facet. So what I did is, I'll show you
So I guess in Haystack, a facet could be any sort of arbitrary determined attribute.
Yeah, I think
whatever
arbitrary
makes sense for your context.
Yeah, and again, arbitrary is a really good word because it doesn't have to be. You can make up the facet when you're indexing. It doesn't have to be something directly from the data. You could some random. You just assign every document like a random digit, and that's the facet now.
I don't want to sidetrack you.
There's no sidetracking now.
Okay, great. But on WDL, the project that Chris Adams works on, they on the search page has just a bunch of examples of facets. If you want to pull that up.
Oh, okay. Be good because my example of facets that I want to show is not that good.
Yeah, if you just Google WDL, which is World Digital Library, I'm horrible. I don't know the
WDL.org?
Yeah, that one. And, pull up an actual, search.
Okay. I don't know what I should be searching at. Cat. Okay, yeah, these are all facets here. This is, if anyone's familiar with Simile Exhibit, that's a great example of how you can use facets.
And Amazon uses them all. I mean, Amazon's the par excellence, right?
I think it's easier to understand the idea when you see it and can point to anything.
And this is where I skipped over a slide that said querying versus filtering. This is filtering, where you basically just got data that doesn't need to be analyzed, and you're just limiting the set based on that data, versus querying, which is going to be looking through indexed textual content. So, if you want to look at the code, and you point it's on GitHub, Benelo, CIA Factbook. And what I wanted to do was just take a list of countries. Again, it was really right here. It's very simple, and just show that you can a couple ways of looking at it. They're all very similar, but just a little bit of how you'd use Haystack. So to start, we've got a countries list. This is just it's like a 3-line, 2-line view. We're just listing the countries. It's just by ID. There's no sorting. We can do a little search though. Search anything where a country is there. There's no. Okay, so there's one result where Indus is present and it's of the Republic. Okay, that's done. This is not using the search engine. The way that was done is just use a manager. method here. So it's just searching for, it's doing a case-insensitive contains query on the name of the country and the body. And then we're just filtering if the government date value is there. That's just a character field. So pretty simple. But what we can't do, and if we wanted to here, is we can't do things like change the value, the relevance of the documents, or do synonym searching. Someone searches for, now I'm blanking on geographical terms, but there's a lot of geographical terms which have synonyms, and a geographer even might look at some of these and say they're distinct, but depending on your user base, you may just want to lump them all together. Mountain and hill, you might just, you know what, those are the same. Anytime we search for those, it's the same thing, and you'd index those words as basically the same.
Yeah. So on your default search thing, when you first did it, you said you put indecent. Does the default already start cutting up words because Australia came up? So industry and indus is
no, it's just looking.
Well, with the I contains, it probably did.
Yeah.
But Elasticsearch won't do that.
Exists something.
Yeah.
Okay, I get it.
So now we do a little bit differently. Now we're going to spell words incorrectly.
Yeah, see, that time it only
That's only
came up.
looking for the word.
Yeah. And one thing you'll notice, this is the default haystack search view. All I did was hook in the haystack URLs. I didn't configure anything else. That was it. So it's doing text search on the field that I configured as the textual field. And then it's giving me this list here. You see the checkbox for countries, which is probably a little bit confusing. The default form is the model search form. And what that does is actually provides a list of every model that Haystack is searching and will allow you to search through them as you see fit. As is, I can't see a reason to use that, but it's there and it's good for kind of seeing how your data is set up. Another thing to keep in mind about Haystack, and this is kind of neat if you've seen how data, let's say, goes into Elasticsearch. What Haystack is doing is basically it's adding in information about your object, about your Django object into the search engine as well. So basically it's adding in the equivalent of a generic foreign key. So when you get that result back, you know what object it's associated with, which means you can very quickly do lookups on it.
All right, so how exactly is the structure? Are you making a query to Haystack, which delegates then to Solr or Elasticsearch? And when it returns, what is it returning you? A list of IDs with models associated, or?
It's actually what it's just returning is JSON.
Okay.
It's returning it's called the hit list, and it's an object, and it's just a list of all these JSON objects, and each object is going to be returned with let's say the title or certain fields from that object. Those fields include
those fields are everything that you indexed initially.
Yes.
Okay, so you don't have to then go and query for the object from your SQL database,
right?
Unless you want to.
Yeah. If you want to get other attributes from it,
other attributes that you hadn't indexed initially.
Yeah, or that you hadn't stored.
Okay.
Because you can.
Yeah, sure.
So, yeah, it's just that's what it's doing. It's pulling back. It's like you can rename it in settings like Django, CT, and some other two fields. It's going to be the name of the model and the ID.
So if you index or store everything, then you never need to hit your SQL again. You just have one backend, and it returns everything for you. With the exception of you have to probably generate whatever the URL is to look at the full version, because I'm assuming that your
so
for example, your search results, the items that you return with your search results, I would assume would be a subset of all of the items on your individual item page, correct?
Yeah, it'd be the items that matched your search.
Yeah.
Okay.
Yeah, but so for example, if an item is India, it's got
a bunch of attributes.
The ones that you display on your search results page,
mm-hmm.
You're not going to want to display the whole item.
No.
You're going to want to display that on the individual item page.
Right.
So you're going to probably index a subset of all items of that model
Well, what you're going to index is not going to be based on what you want to display. It's what you want people to be able to search and find.
Exactly.
Yeah.
So index and store, I should say. Sorry.
Okay. Yeah. So storing things would be based on, typically just what are pieces of data you want in the results list that you don't want to go back and look at for. For example, I don't really think that I don't know to what degree finding the absolute URL for an object, how much time I've added that in. Thumbnail URLs, that's gonna that could be it's gonna hit a cached table, but why do that? It's just a little
why hit your SQL database when you can store everything in there?
Right. So those little things that have to be calculated or generated, just generate at index time. It slows your index time a little bit. But that's something that's going on in the background.
Yep.
Yeah.
Does it have that? Since you mentioned that it's working on a document, does it have to digest the entire document all at once and hold it all in memory at the same time?
I think what you're asking, the short answer is no. You're talking about when you're searching?
When you're building the index.
Oh, okay. Then yes, that's okay. So does it have to store the document that's going to be sent? Does the application? Yes, and that's where there's a flag called batch size. You could, in theory, run out of memory generating the content. So let's say you're going to generate a template, and you want to send this template to the search engine. That's going to be, the generated content will be part of a JSON object, but it's basically a Django template. The default batch size is 1,000, which is typically going to be fine. But let's say you decide to raise that to 1 million. What it's going to do is it's going to run through, when it gets to 1 million documents, do a bulk update. So if you had really big documents or a lot, you could run out of memory at that point. So it's all going to be in memory until it's sent to the search engine. Is that what you're asking?
Right. Can you fix the size?
You can change the batch size.
Okay.
The point of that is that you can send individual documents to the search engine, but you want to do a bulk index. It's going to be a little bit more efficient. So,
but if you had like a single document that was like a terabyte, then you're going to have to do your own.
Yeah, I think you'd be SOL.
Yeah.
There's probably strategies around that, though, like breaking up the document and doing something with it. I just don't know. I'd like to think I could figure it out if I had to, but right now, let's see. We're going to the customized search. This is now the one difference you'll notice here is that it looks just like the field we had for the countries list, and same thing here. It's a little different now, but we can search based on the type of government as well. So if this was all we had to do, it's not really a big improvement. And then faceted search, you can see there's no facets because we have no results yet. And this is why I said my facets were not that great. As you can see, there's a lot of parliamentary and Republican. What it's doing is it's breaking up. It's actually tokenizing those facets, I believe. I have not had to deal with this, but I have read about this issue on some of the mailing lists. There's a solution out there if you have to deal with this, but I don't have it for you right now. What it's going to show you, though, are those facets and how many results match that. You're going to get a count, and then you can use those further to filter your list. So again, we're just filtering at this point, but based on a search. So the differences are very slight, and it's just illustrative right now to see them on the front end. There's not much here. The differences in how these are set up. So the default that I showed you is just including the default haystack search view. That's all it is. There's zero configuration there. The customized search, the only thing we've done here is given it a new search class. This is just a little factory to provide a thread safe view. So we're using the default haystack view, but we're just getting a different form. And the form command, that's where the search action actually takes place. Again, you don't have to use this form. You could do this kind of how you want it, but that's what haystack ships with, and it's convenient to start with, at the very least. And then the faceted search, see two differences here, or three, actually. We are naming the search query set. All these views are going to have a default query set you start with. So think about how you have a query set, and it's chainable. You might start with that, like you would like a class-based list view. We're giving a default query set to start with here, and we're telling it, we're saying, facet on this field. Otherwise, we're not going to have those facets generated. We have to, basically give the search engine the instruction to do that. And then we're using a different form and a different view to render those. What I'm going to do is just show you the. So here is the slightly customized search form, and the search form comes with one field, which is Q. It's a character field you're going to use to query. All we're doing is adding in one more field, and it's a choice field based on a generated choices list. And you can see it's pretty straightforward. We're just giving it an auto query that we're basically letting haystack make the decision for what type of query to make, if that's present. And then we're just filtering based on the government type. We're going to do either one of those. If there's no query, we still want to be able to filter. If there is a query but no government type, we still just want to do the query without filtering. And this load all is going to be if there is some data from the objects. Database is going to just do one SQL query to pull back just at least a little bit of that data initially. So at the very least, what I hope this shows you is that the API is basically the same as you're used to working with, and there's nothing magical going on in the haystack end. It's all pretty straightforward. The one thing we want to address here, lastly, is the search index, and this is the mapping I was talking about. We provide a text field, and we call this is the document. Every search index has one field that's the document field. And I'm actually going to get that data from the background. We could pull it from a template and then generate that template, but here I just get it directly from the model. Get the name, same. Sort name is it's a field that doesn't exist in the model. You see the model attribute is exactly the same. And what I did here is did not index it, but do store it. So if you actually get the name stored twice, but since it's not indexed, it's going to be stored as the string, which means that that's something we can sort on later. We wanted to sort all these things by the name rather than relevance. And similar here, we have a population field that's an integer rather, so we're not going to be searching that like a text field, but it is there, and that's something you can query as well. And then the one little thing we need to define is the model. Where is this coming from? You can also define a query set method. You want to get a very specific query set. So you could have search indexes, two different search indexes running the same model, but different query sets. We wanted to piece it apart differently. And again, this is very simple, just to show you. This is enough, I think, to get started, to get yourself to a point where you're really confused. So, like I said, this is all on GitHub, and it is basically set up if you wanted to run on a Roku. It will run there as well. So.
Have you guys done any sort of performance benchmarks regarding using this abstraction layer, let's say for example Lucene, versus directly hooking it in?
No, and for what we're doing, it's really not an issue. So you're talking about using, and when you say abstraction layer, you're talking about versus Lucene. Are you talking about using Lucene, like the library, versus Elasticsearch or Solr? No, I haven't. I know that if you've got a large Java application, then it makes sense to just use Lucene. But otherwise, I don't know. I haven't done any benchmarks. I haven't stumbled upon any. I wouldn't guess there'd be a huge difference. mean, most of the performance issues are going to be in indexing the content, really, and then looking it up.
Can you give an example of maybe a site or a project you've worked on and where it works well and where it works poorly? Like a live demo?
Sure. I can show where it works poorly. So, project. Here's a, this is just searching coffee. See, the one thing that you see here is there's different model types. You have businesses, you've got some posts, deals here. The
So it looks at the different facets, the titles, and then, I mean, it says the maintenance repair. How do you think that got in there?
Espresso repair,
Yeah.
coffee,
Oh,
machine
this is the
repair.
This is the problem. Doing some things with synonyms, trying to get synonym tables, and when you start making words equivalent, you've made the words equivalent. That's been hard. Some of the other challenges, and some of this is probably just has to do with needing a better understanding of how the queries are being made. Is working with longer phrases that. If I would work with that phrase directly with, let's say, just against the search engine, using like a very vanilla query, I can get the results back. But when I use some other, like the auto query from Haystack, I'm just not getting anything because there's too many matches. Like an OR query will get you the result, but saying the phrase won't. So you can see there's a sort. You can sort some of the results here alphabetically. Because there's a sort name on that. If you're just using like Elasticsearch, you don't have to. You can use a kind of like a nested field to do this. So one component of that field is analyzed and the other isn't. And there's actually a map view here. So this is with Mapbox and. You can see the results will change. So you can do, you can use like a distance search. You can also use bounding boxes and radius searches as well. Just go nice, but again, some of the problems were synonyms have been a real problem.
Do you ever look at what people are searching to try to figure out what to set as synonyms?
Yeah.
And how do you do that?
A very simple way, and I'm not ashamed to say that, using custom Google Analytics events. Just put in the search term or terms, and then usually getting like the number of results. Adding that into the event, and so Google Analytics should just get this list of what do people search for and how many results do they get. You can start to see that. That's a primary way to look at and record that. You could do that at the application layer too, but it's just so easy to get the data. With synonyms, you've got to be concerned about what is your content, like what kind of content you have. Who's your user base? Like, are they looking at like what you might have the same content with different user bases, different primary user bases. You might have different synonym tables. So that's been.
Can't you apply like some sort of fractional boost to synonyms?
Not that I'm aware of. The way you're basically either mapping words to another word, or you're just declaring which word's equivalent in the same. Either way, yeah, because what you're describing, that'd be awesome.
I mean, so it's going to be indexing after. If you're going to have an inverted index anyway, it's going to have to keep a separate mapping between that inverted index word, the index word itself, and your list of synonyms. And it's going to have to do, basically a binary and.
Only do synonymization on the query, you could, but usually, not usually, I should say. If you're doing the synonymization at the index level, when you're indexing, you're not going to have those. If you're, let's say you're mapping words to another word, if you're mapping espresso and tea to coffee. Whatever espresso and tea were, that you're just going to have coffee. That's just have. So there might very well be. I don't know. And that'd be one of the things where one of the use cases where you're going to have to start going beyond what Haystack lets do. It's a great tool to get started, but when you start seeing some of the more advanced things you can do with many of these search engines, like you could do nested documents, where you're getting scores based on documents that are somewhat related. You're not going to do that with Haystack. Yeah.
Are some of the synonyms are they just straight matches between two strings, or is it sometimes context sensitive? For example, like bad can sometimes be good, except for when it's bad or when it's something else.
It's just basically it's just a word. There are two formats you can use, at least with Elasticsearch. You can use the Solr format, which is a text format, and you can also use WordNet, which is a compiled database from some department originally at Princeton. But you can use either
Psychology.
one. Pardon?
It was a psychology department.
Psychology? All right.
It's meant to be a taxonomy of human concepts.
Okay, gotcha.
Bob's a
But you
linguist.
can use it as much worse.
You can play with WordNet through the NLTK ships with it. You can see what kinds of things it returns, but you sometimes need to know part of speech to get good results from WordNet.
There's also a Java snippet I found and used successfully to convert WordNet database into a Solr formatted text file. It's just readable. You can see it. You can make, okay, these are words with commas. Okay, I get it. You don't have to go through anything else. Yeah.
So you didn't do this in your demo, although you touched on it in the PowerPoint, and I sort of was thinking about it right before you started presenting, that you can make, instead of giving fields to when you specify what you want indexed, you can give it a template, right? And you can use the Django template language or whatever to put together the document that's actually going to get indexed. I just had this idea before you started presenting, and I wonder if you tried it or thought about it, which is can you use other template language aspects on those? Can you put filters and tags and things on those?
Oh, in the template?
Yeah, you?
It's a regular Django template.
So, does it get served as one? Like, if I put something in, if I made a filter that capitalized everything, or use something local.
The only difference is, of course, it's not being served from a view, so you're not going to have a request. But it's.
But you can still manipulate it that way.
Yeah.
That's interesting.
It's some of these, some of these results will come up, and it's really confusing to someone. Like, why is this result in here? Because in some section of the document that wasn't displayed, it was there was an iteration over the categories of the business type, and one of it's just like a regular for loop. You can use tags in there. I thought you were going to ask if you could use another template language. Sure, you could use Jinja. Yeah. You just described where you saw model attribute. Basically, that's a keyword. Just use template. Specify the template name. And usually it's going to be in the search, under the search, and you just name it based on whatever model you're using. There's a default name, kind of like with cross-space views. There's going to be a default name with the _edit _list, just like that for your model. And it's just a Django template.
We actually use that on the Foundation site for blog posts to iterate over tags and write them out, and also to strip HTML tags from the posts themselves. So it's just the textual content.
Cool.
For the geospatial search, do you have an example that is easily accessible that you can show us?
You mean the code?
Yeah. I've just never I've never actually seen the code for
it's just a search view. Okay, so this is going to be a little different. I didn't use the default haystack views. I created views that were more aligned to the Django class-based view. They're on Vanillope/Elasticstack. It's basically some helpers for working with Elasticsearch, and there's some views in there, some mix-ins that are applicable anywhere. But basically, I just have a query set, a search query set, and clear.distance. So like when we're faceting here, we're adding the distance feature on there, and then you give it the center point. You want to add the distance from that center point, and then it's just ordering by distance rather than by score. I forget why I decided it was necessary to filter by whether it's geocoding or not. And then additionally, potentially use a bounding box. So it really gets pretty simple in this case. And you're just using points like from GeoDjango. You could get away with using this if you didn't have if you weren't using GeoDjango, you weren't using PostGIS. Let's say you've got some other projects, Postgres or MySQL or SQLite, and you just got a latitude and longitude field. You just feed that data into a location field in your, let's say, an Elasticsearch. You're just going to prepare it differently. So you have a method for every field. You have an optional method to prepare that data, and you could just prepare location. And what that does is it grabs the object's latitude and object's longitude and concatenates them into a string that kind of looks like a point field and just feeds that to Elasticsearch. So that's the only thing that, if you're only using geographic data for this textual search, you can get away with just doing that.
So you said that haystack is an abstraction on top of things like Pi, Elasticsearch, and I'm guessing there's like a Pi Solar or something like that as well. Do you know if, so I know that you mentioned, Apache Tika is one of the Apache things. It's like nuts for scraping and, all that. Or do you know if there are Python layers of abstraction on top of that, and if or haystack would be able to use any of those? Or haystack has extensions to anything if non-existent?
I don't think it does. When, a couple of years ago, I was looking for ways to do that kind of text parsing, I don't remember seeing a whole lot in the way of Python-based interfaces between, let's say, Tika. I think in that case, what you'd be probably better off using is something like a plugin for the search engine itself that can grab that. Or, the way I would think about doing it, which is a really hackish way, but this is the quickest way to do it, is basically run Tika as a service, and then when you're preparing stuff, read it, but that's like the quickest way I can think about doing it. I know it's probably the worst way.
I know kind of.
I have one more question. That the substring search, it doesn't work by default for haystack on at least Elasticsearch, right? Like earlier when you used your comparison, Indus matched on Australia because it matched on industry or something like that. Whereas when you did the same search through Elasticsearch, you only got India because it only matched in the Indus.
So this is where debugging or tweaking your analyzers, among other things, comes into play. So haystack. This is, by the way, I don't think I mentioned this. I was using Haystack 2.0. That's in the beta. The PyPy versions are 1.4, 1.3, and that doesn't support Elasticsearch. So the version that's does support Elasticsearch and when you're mapping your search, you're creating the mapping for your search documents, you can define the analyzer or analyzers, one of these fields. Haystack just gives you one. Like there's no simple way, and that's the snowball analyzer, which does
white space.
And it's going to do some basic English language stemming as well. So that's where you might want to change. Maybe consider they're doing some n-gram analysis. That has been another confusing thing for some people. Is finding like, hey, I searched for this part of this word, but that's not how it's searching. It's searching based on like words or matches of words or components of words, but not just pieces of like the letters.
Yeah, I guess my question was around: have you seen a big performance difference if you implement something like that, like an n-gram tokenizer or something like that? Because obviously the inverted index is going to multiply.
I mean, the corpus that we're generating is pretty small, like for that project. So that's not really an issue. And my concern with something like that is less partial searches like indus matching industry and more components of words or similar words matching. That's, I guess, another gotcha is that there are trade-offs when you're analyzing these words. You're going to pick a way to do it, and that means another way of searching is not going to work.
Well, you could run multiple indexes, though. You could have multiple.
Right.
You could run, 3 or 4 searches against multiple sets of differently indexed things.
Yeah,
and have all those searches run in parallel if you wanted to, and then do the filtering yourself. But that would be painful as well.
Yeah, but it's not a great concern to be able to do that. But yeah, that's so. Yeah, if you're using also multiple languages, having multiple indexes, is what you want to do as well.
And you have to make sure you analyze your queries the same way you analyze when you're indexing.
Yeah,
that's.
How much do clients like to pay for search? Fair enough.
The thing is that a lot of clients, I think, don't understand. It's like when we're looking at these little examples, it's just a search box, and you just get results back, and you can do that, and you're like, well, how is it any different than what you can do with Google? There's a technical implementation side, which, to be fair, isn't for a lot of folks. That's not the hardest part. The hardest part is like trying to figure out the strategy, like the technical strategy for, okay, how are we going to index this, and how are you going to query it? If you're using Haystack, a lot of those things will be answered for you. The questions will be answered for you. They're not going to be optimized in many cases. Like it's pretty simple. We're talking about changing how you query and how you analyze the query. Because you analyze the query too. You have a lot more control over that if you're generating these advanced queries directly versus just what Haystack would do. That's not the knock on Haystack. It's awesome.
One thing I ran into was if the model doesn't have an easy way to find out when it changed last, that's an issue, because then update index, I mean, if you don't know what to do, it updates everything every time, so it doesn't know.
Right. So that's where, this is something I might have deleted the slide. Indexing strategies is also another thing you need to be concerned about, not just like how the content's in this, but like when and how content's removed and added. I would think so running just like a cron job for some of this content, because regardless of what else we did that has to be done, when you have content that expires, regardless of whether it's touched or not, you need to have some external process remove it. But you can also have content, you can index using on like a save signal, or you can do that real time, or you can use a queued index, so you have that, have salary manage that. That gets rid of part of that problem. So you're not worrying about when it updates, it goes in the queue to be re-indexed. But you're right. If you don't have that, then you have to use one of those strategies, or you have to update your entire index.
I can imagine that would be a huge gotcha. I know you didn't touch upon files and certain documents, certain binary files.
Oh, as far as like the time or
Right.
knowing when they were changed?
Exactly.
Yeah, you'd well, yeah, so like I said, it's ORM oriented. So there's a, you would do this by specifying the modified field name, say, or something like that. And so it's touching the ORM, it's looked at an ORM. I don't know if there's let's say a way to get a method, add in a method that's actually going to search something else, let's say in the file system, like pull the last modified date from the file, and then search it. So I think there's room to do that, potentially. Yeah.
When you're building your indices, do you always have to rebuild from scratch, or can you build in spots?
You can build. So, well, if you're rebuilding, that means you're just doing the whole thing. So, Haystack doesn't provide a way to just drop parts. Let's say arbitrarily, like drop this model, all index documents of this model, and then update them again. You can remove, let's say, you can either clear everything, or you can remove documents because they're no longer supposed to be indexed. That's what Haystack lets you do. You could go in arbitrarily, let's say, with like using Elasticsearch and just say, okay, I want to wipe out documents that match those, this list of documents or something like that. You could do that there, but not through Haystack.
So if you had a document that got modified, then you would have to rebuild the index instead of just extending it.
Oh, no. So if you have let's say one document that's modified, and assuming you're not using a real-time index or a queued index, which is going to update that, you might run a cron job that updates the index for all items where the age is 1 hour. This is an hourly cron job, so it's going to do a query for all objects that updated last hour, and then it's going to update the index for those documents. Does that answer your question?
I think so.
Okay. Any other questions? Cool.
Okay.
Thanks. If
Thank
you guys
you
do have
so
any other
much.
questions, give me a
Thank you so much to Ben for speaking tonight, and for the beer. Thank you to Sunlight for the space. We appreciate it. I'm going to be probably coming up in the next month or two with setting out a survey on sort of what you guys want to see more of, format, style of meetup, that kind of thing, just to kind of switch it up a little bit. We have a speaker for next month, and I'm completely blank.
Jen?
Yes, thank you. It's actually a tutorial class on deploying to Amazon, I believe. Is it?
Yeah.
Thank you. I've heard she's done it before, and I've heard it's good. But for May, June coming up, we still need speakers. So if you have anything you want to speak on, if you have any ideas, you can submit ideas. If you don't want to speak, ideas are still welcome. Submit them to the meetup board. If you are interested in speaking, contact me and pitch an idea, or contact me and say, hey, I can speak, but I might need some help kind of feeling out some ideas. We can help you with that too. Next month, I think it's the second Tuesday in April. See you guys then.
Awesome.
Oh, also, we need a few people to stay and help, and the rest of you, please leave. And do not injure yourself on the way out.
Is anyone going to PyCon?
Oh, PyCon, yeah.
I'm not. I'm just curious.
Across the room, high five.
That's in San Diego this year?
There's a big Elasticsearch presentation there, too.
You're doing what?
There's a big Elasticsearch presentation